Hello, everyone. Welcome to my presentation. My name is Godfrey Omolo. I am from Kenya, and I've been studying at the University of Oenheim. I just completed my PhD last month. It's my pleasure to present to you part of what my work has been. And the title of my presentation is Comparison of Mechanized Conservation Agriculture and Conventional Disc-harrowing based on a 3-year on-farm experiment. And this is experiences from Zambia. I also greatly recognize the team that has been part of this work. Now, as an introduction, research has shown that low mechanization as well as unsustainable agricultural practices are some of the leading causes of poor yield and soil degradation, not only across sub-Saharan African countries, but also world at large. However, conservation agriculture has emerged among researchers and policy makers alike as a candidate for sustainable agricultural mechanization. Now, talking about conservation agriculture, this is an ecosystem-friendly farming practice that is anchored on 3 principles of continuous minimum soil disturbance, ensuring at least 30% soil cover, and crop diversification. Conservation agriculture has actually spread worldwide. However, its adoption across sub-Saharan African countries is still rated low. Now, among the countries where conservation agriculture has been promoted for a long time is Zambia. So with over 3 decades of promotion, Zambia is rated the second country with the largest farm area under CA after South Africa. Presently, 14% of arable land is considered to be under CA. CA has also recorded various positive impacts, both on agronomic, socioeconomic, and also environmental aspects. Nevertheless, CA also is still faced with various constraints. So among the constraints that smallholder farmers experience is labor intensiveness. CA is extremely labor intensive in the absence of mechanization. Now, against the backdrop of low yields and labor intensiveness, the recent readjustment in farming and land ownership systems across sub-Saharan Africa, and particularly also in Zambia, has seen the rise of medium-scale farmers. And these medium-scale farmers, as is also in other countries across sub-Saharan Africa, tend to cultivate relatively larger pieces of land, so between 5 to 100 hectares, and they produce for the market. Besides, they also employ some level of mechanization, either animal draft power or tractor and associated implements. Now, these emergent farmers or the medium-scale farmers that are emerging across various countries in sub-Saharan Africa presents a new perspective for conservation agriculture. So as to whether conservation agriculture, mechanization, and the rise of these emergent farmers can be synergized to upscale CA adoption and overall productivity in Zambia still remains unanswered. And as to whether these emergent farmers could be the missing link for mechanized conservation agriculture also still demands more questions, more answers. This study sought to bridge the gap in literature. Now, recent CA research across sub-Saharan Africa has mostly focused on smallholder farmers and also small plot experiment either on farmer fields or on farm stations and using manual tools. And despite the fact that research shows that mechanization may incentivize CA adoption across sub-Saharan Africa, little research actually has forecast on the performance of mechanized CA using 4-wheel tractors. And therefore, we sought to fill this gap. And the aim of our study was to demonstrate or investigate the short-term agronomic and socioeconomic differences between mechanized conventional tillage, in this case, disc-harrowing, and mechanized conservation agriculture. Now, the the short-term aspect is very key, since the first few years is crucial in determining whether farmers who often have short-term needs and trade-offs will or will not continue to practice conservation agriculture. And we also assess the cost and the benefit of mechanized conservation agriculture from the scenario whereby farmers can hire agricultural services without having to own tractors themselves. Now, this study was conducted at Golden Valley Agricultural Research Trust, which is situated in Chisamba District, Central Province. And this was a collaborative effort between the University of Hohenheim and the local partner, the Zambian German Agricultural Knowledge and Training Center, AKTC. The study site is located within the agroecological zone 2A, which is characterized with annual rainfall between 700 to 1,000 millimeters of rain. Prior to the experiment, the plot had been fallow for 3 years. So 15 hectares of land was set aside for this experiment, and the experiment was purely rain-fed farming. So we had two big plots, so maize plot and the soya plots, which were the two crops were rotated after every season. So basically, we had three tillage treatments, which were replicated 4 times to yield 12 experimental units. 3 different tillage treatments included CA treatments as well as conventional treatments. So the CA treatments were direct seeding, which involved the use of direct seeder or no-till planter, directly planting in the residues without any soil disturbance, initial soil disturbance. The second CA treatment was the reaping tillage, which included the use of 2-row reaper, and then afterwards planting on the same reaped lines. The final treatment was the conventional disc-harrowing, which involved initial burning of the residues on the plots, and then using a disc harrow to completely disturb the soil before planting. Now, all the operations from land preparation, planting, fertilizer application, weed control were done by using locally acquired implements mounted on a 60 horsepower tractor. So this was crucial because this is the size of a tractor that is common among the medium-scale farmers or the emergent farmers within the locality. Throughout the season, we are also keen at collecting various agronomic and socioeconomic data so that we'll be able to make a farm comparison between these 3 tillage treatments. We also had opportunity to do on-farm demonstration with the farmers from the locality. Now, briefly on to our findings. So we look at the effects of tillage on the crop yields. First and foremost, the 3 seasons varied greatly in terms of the amount of rainfall. So the first and the third seasons were fairly dry, while the second season was actually wet. So comparing the maize yields, so the first and the third seasons, which were fairly dry, recorded marginal yield differences across the 3 treatments. While in the second season, which was fairly wet, disc-harrowing and reaping tillage for maize recorded significantly higher yield than the direct seeding. Now, in terms of soybean, in the first season, which was actually dry, CA treatments, reaping tillage and direct seeding recorded higher yield compared to the disc-harrowing. There was no marginal difference. There was marginal yield difference in the second and the third season for the soybean. Now, in terms of fuel and time use, direct seeding significantly saved time and fuel throughout the season, across the 3 seasons and for the two crops compared to disc-harrowing and reaping tillage. At the same time, this result shows that producing soybean and maize under disc-harrowing and reaping tillage significantly require higher time and fuel use per unit area compared to direct seeding. So in general, direct seeding actually requires almost half the energy, half the fuel and time to produce either maize or soybean per unit area compared to reaping, tillage, and disc-harrowing. Now, in terms of profitability, land preparation costs saw relatively lower hiring costs for direct seeding. This is critical because there was no cost incurred for direct seeding. And since all the other operations were held constant, at least farmers could still save some amount of money by choosing to do direct seeding. In terms of profitability, it's important to note, or it's good to see that in the two dry seasons, that's the first and the third seasons, there was generally higher gross margins for the CA treatments compared to disc-harrowing. And this was contributed by the good grain yields in dry seasons. Now, in the second seasons, which received high rainfall and better yields, coincidentally, the profitability was low. And this was because of the low or the poor grain prices. That is as a result of good produce countrywide. So this result actually shows that farmers can be economically secure, especially in dry seasons, because they will still get good profit margins compared to the disc-harrowing or conventional practice counterparts. Now, in conclusion, our results actually have shown that mechanized conservation agriculture offers great opportunities for medium-scale farmers to increase their productivity per unit area, and this can also have spillover effects to smallholder farmers. The time and the fuel savings in mechanized conservation agriculture also may enable farmers to do other non-farm activities, and also importantly, contributes to lowering carbon emission footprints. Most importantly as well, mechanized conservation agriculture results here have shown that it can be profitable and that it can also be economically viable in the short term, which is very crucial, and especially in dry seasons. And if farmers can hire machinery, they can still get the same results. And most importantly, our result shows that there is no yield penalty, at least in the short term, in the 3 seasons that we have done this work. However, more research is still needed to increase enabling environment, and also investment is needed as well as appropriate policies regarding mechanized conservation agriculture for Zambia and across sub-Saharan Africa. So part of this research we have published in Soil and Tillage Research, and I will finish by appreciating and thanking all the funders, the collaborators of this work. Thank you very much for your attention.